integrate it, but also has some kind of somewhat, I'm not sure if it's tricky or just maybe a little bit complicated evaluation of the integral using that inverse cosecant. So that's a nice review there. First thing, I always like to factor that 13 out of the integrand because you'll just make it a little easier to work with. So then we have kind of a classic integration by parts, t inverse cosecant t dt. And we know that the inverse cosecant of t is easy to differentiate. We have that if you have the derivatives in the integral sheet, or you can look it up. That's easy to differentiate. And this function, of course, is easy to integrate. If you try to do a u substitution, it's just not going to work. So the best idea here is to try integration by parts. So we'll let this be our u. We'll let u equal inverse cosecant of t. And then we'll let dv equal what's remaining, which is the t dt. Now du, the derivative of u, which is the inverse cosecant, is negative 1 over the absolute value of t on the square root of t squared minus 1. So you can just look that up. That's your derivative of your inverse cosecant. Now to find v, we just integrate t dt, which of course is just t squared over 2. That's an easy integrand. Now don't worry about this absolute value here, because you notice your limits of integration are both positive, so t is not going to be negative, so we don't have to worry or even write the absolute value other than just in that one moment. Okay, so we remember the integration by parts formula. The integral of u dv is equal to uv minus the integral of v du. Okay, and so in this case, the integral of 13, 2 on the square root of 3 to 2 of t inverse cosecant t dt will be equal to, so the 13 is going to tag along all the way in the front, so just kind of remember to put that. And we have uv, so that's going to be, so uv, which is, I'm going to put the v first, t squared over 2 inverse cosecant of t minus the integral of v du, so that's going to be t squared over 2 times this negative 1 over, and I can just write t squared minus 1 dt. And I'm not going to write the limits. I'll evaluate the limits in a minute. So, okay. So, how does this, let's just look at this inside part and see how this cleans up. If I can get another little bit more room. Okay. So, we have the 13. This part is going to tag along. This negative here can make this a plus. The t here and the t squared here we can cancel. We'll have a 1/2 that can come out in front. So now we're just integrating 1 over the square root of t squared minus 1 dt. And you could do a little u sub there. U equals t squared minus 1. So du is going to equal 2t dt. You can solve for dt, it's going to be 1/2 t. Oops, I lost the t right here. And so that, you get du over 2t is equal to dt. So you'll see that when you plug that in, the 2t will cancel. Let me just make that a little cleaner. Will cancel, the t will cancel, and you'll have a 1/4 out in front, and it's going to be 1 over the square root of u. So we've got this stuff. So this will be a 1/4 in front, and then you're going to have just the integral of 1 over the square root of u du. And then, of course, the antiderivative of that is going to be, so that's just the square root of, that's u to the negative 1/2 power, right? And so you add 1 to the exponent and put it over it. So that's going to be, the antiderivative of that will be u to the 1/2 over 1/2, which is 2 square roots of u. So you'll have this 1/4 times 2 square roots of u. Well, what was u? That was t squared minus 1. So I'm skipping a few steps there just to try to finish it quicker. Let me see if I can get some more space. Okay. So now we need to evaluate these limits. So we have the 13 in front. Now the 1/4 and the 2 here you can cancel, so that's going to be 1/2. I'm going to put 13 over 2. So I wrote a 3. This video is, so 13 over 2. So this will be t squared inverse cosecant of t plus the square root of t squared minus 1 from 2 squared to 3 to 2. Now we're ready to evaluate. We have the 13 halves out front. Plugging in 2, you're going to have 4 inverse cosecant of 2 plus, this is 4 minus 1, which is 3, so the square root of 3, minus 2 divided by the square root of 3 squared is going to be 4/3 inverse cosecant of 2 over the square root of 3 plus the square root of 2, so 2 over square root of 3 squared is 4/3 minus 1. 1 is 3/3, so that's the square root of 1/3. Okay, now what is the inverse cosecant of 2? That's the same as saying the inverse sine of 1/2. So the inverse cosecant, remember cosecant is reflection of the sine, so the inverse cosecant, you just would flip the ratio. So you're going to do, and do the sine. And then this one, of course, is going to be the inverse sine of the square root of 3 over 2. And so what angles give you those ratios, that's going to be on your unit circle, or hopefully you have that memorized. That's the inverse sine of 1/2 is, of course, pi over 6 plus the square root of 3 minus, okay, the inverse sine of square root of 3 over 2 is pi over 3, which means the inverse cosecant of 2 over square root of 3 is also pi over 3, plus, now the square root of 1 over 3, you can think of that as 1 divided by the square root of 3, or you can think of that as the square root of 3 over 3 if you just rationalize it. Okay, we're getting close to the end here. So this is 13 over 2. This is 2 pi over 3 plus the square root of 3 minus 4 pi over 9 minus the square root of 3 over 3. Okay, so you have a whole, this is 3 square roots of 3 over 3, take away 1 square root of 3 over 3, so that's 2 square roots of 3 over 3 for that part. And here you can multiply this by 3 over 3, so that's 6/9 minus 4/9 is 2/9, 2 pi over 9, and again you can multiply this by 3 over 3, and you'll get 2 square roots of 3 over 3. And then finally, you can multiply through by the 13 halves, and the 2's will cancel each, and you'll get 13 pi over 9 plus 13 square root of 3 over